simple circuit. Okay, in this simple circuit, we have 10 volts of power supply, DC power supply, and a switch and two resistances. Okay, two resistors, one is 20 ohms, the other is 40 ohm, and to 40 ohm, a 0.5 microfarad capacitor is connected in parallel. Okay, so the question asks, what is the current at t equals 0? Of course, the current will be this way. Okay, and what is the voltage between, or the potential difference between point B and C as t goes to infinity, or the circuit reaches the steady state, and then after that steady state, the capacitor voltage will reach to maximum value, of course, and then at that instant the switch is opened again. Okay, when the switch is opened, as you see, this part of the circuit is gone, and this R1 is hanging now in the air, so it's not also used, but only we have this circuit now. So what's going to happen is that the capacitor will be discharging through this resistance. Okay, so it will just lose its voltage or charges through the current, probably in reverse direction again. Okay, but the question is that when the charge, at what time the charge reaches to it goes down to 20% of its original value, which is the maximum value. Okay, so this is what we would like to do now. Okay, so first let's handle t equals 0 business. Okay, at t equals 0, all the capacitors are short circuit, so it doesn't, okay, it means that, so these points are just short circuit. So let's draw the circuit again. Okay, so please do not hesitate to draw. So switch is closed, by the way, here. The switch is closed, and we have 20 ohms there, so we have 40 there, but 40 is just short circuited. So we will not use 40 because it's just gone. Okay, because this short circuit just gets rid of this 40 ohms, because when the current goes down, it doesn't go here, but it just simply goes around, and then this 40 is not used in the calculations. So this is plus and minus 10 volts, and the current is flowing this way, and this is I0. And simply, because this part is gone, it's just the short circuit, it's just 10 over 20, I0 is just 0.5 amperes. That's very simple. So initially, C is short. Don't forget, I put a star mark there. So this is very important. As t goes to infinity, C will be open. So when the time comes, we will there. So at t goes to infinity, in other words, the circuit reaches the steady state, no current is passing from capacitor. Actually, no more charge. Let's write it this way. No more charge on capacitor, okay? Because physically, the current is not passing through the capacitor, but the current outside is bringing charges to the plates of the capacitor. But once the plates are filled, the capacitor has been reached the maximum value, and then it will not be able to accepting any incoming charges. So there will be no current going through the capacitor. Okay, that's why now this is open circuit. So when we draw the circuit, again the switch is closed. We have 20 there and then 40 there. Okay, but now this is just empty. Okay, as you see, now nothing happens here. So basically, you can just get rid of these parts. Now we have 40 next to 20 now. As you guess, then infinitely, okay, I infinity means that the minimum current that you will have will be just 10 divided by 20 plus 40, okay, which is just 0.17 amperes. So usually the initial current is high, but after some time is passed, okay, it drops to some small value. And then after this value, the current continues, okay? So the current just flows forever. if this power supply always provides 10 volts, the current will be 0.17. It will never drop to 0 or something. Okay? Okay. So basically, the current is not dropping to 0, but what's happening is that the current is going down to 0.17 amperes. Okay? So the current will behave like that. So the current will start some value and then reach to some limiting value. Okay? So this is I infinity. This is I as a function of time, I0. Okay? So anyway, we have this kind of analysis. But now what will happen is that after when this current value is reached, we would like to find the charge. What is maximum? What is Q infinity or Q maximum? Okay, so what is that? So in order to find that, we know that if we can find this, don't forget, still this is point BC, BC, okay, BC, B and C. So if we can find VBC, then we can find, okay, the charge on the capacitor, because physically there is a capacitor still there, okay? So this capacitor voltage VBC is just the voltage between these 2 points, which is the voltage across 40 ohms resistor. So VBC is given as I times I infinity times, okay, R2. So the current is known 0.17 times R2, which is 40 ohms. Everything, okay, we don't have milli or micro or something. So this is equal to now VBC, but remember that Q equals CV. Now in this case it's VC. So VBC is nothing but Q over C or Q maximum over C, the capacitance value 0.5 times 10 to the minus 6, because it's microfarad. It's given here. Okay, so from this you can find Q max, which is just 3.3 microcoulomb. So we found the maximum charge that was loaded to the plates of this capacitor, which is 3.3 microcoulomb. Now, after this moment, after you reach the steady state, wait, okay, long enough, after a few seconds, maybe a few minutes or something, okay, so that the current reaches to the minimum value, which is not 0, but just 0.17 amperes, okay, then we will open this switch again. So what's going to happen is that automatically, okay, when you have this case, as you see, the left-hand side of the circuit is just gone now. So, but now the capacitance will start to now discharge through this resistance, but not earlier the current was this way, but now it will be that way, because it will be here plus and minus there, so that plus and minus capacitor charges the capacitor will behave like a power supply, drawing the current, okay, creating the current, but in opposite direction. So this is 40. So basically this part is gone, this part is gone. So the discharge is just happening within this small loop, okay? So basically for this one, we can get the time constant in order to find the necessary equation or the charge equation. The constant is just R2 times C. So this resistance times capacitance, and it's given by 20 microsecond if 40 is multiplied by 0.5 micro. Okay, so this is what you get. So basically what happens is that, remember that Q is now starting from Q max, the maximum value from this value, e to the minus t over tau, it drops exponentially in this case. But starting from Q, now the initial Q value is Q max. So the final value for the previous case is our now initial value. It's not Q0 but Q max. Now it says that if this is 0.2 Q max, okay, what is the time? Minus t star again, divided by tau, which is 20. So if I don't put 10 to the minus 6, the time will be in terms of microseconds. So when these two cancels, and do the necessary thing, okay, you get T over 20, which is equal to ln 5, and from this T star, this is T star, will be equal to 32 microseconds. Okay, 32 microseconds. So this is the end of the problem. Now we stop recording.